Welcome back. In this module, we're going to learn how to integrate the functions sin x all squared and cosine x all squared. Please note that sin x all squared and cosine x all squared is commonly spoken as sin squared x and cosine squared x, and we shall use this convention here. In the previous two modules, we learned the technique of integration by substitution and applied it to a variety of difficult integrals. Surely then, it shouldn't be too difficult to integrate the fairly simple functions sin squared x and cosine squared x. But unfortunately these integrals are harder than they look, and that none of the integration techniques you currently possess works. The trick is to utilize a couple of double angle formulas learned in day 3 to rewrite both the sin squared x and cosine squared x in terms of cosine 2x, which is an easily integrable function. Recall the following double angle formulas derived in day 3, which allows you to express cosine 2a in terms of sin squared a or cosine squared a. Solving for sin squared a in equation 3 and cosine squared a in equation 2 therefore gives rise to the following two identities. These two identities are then used to integrate the functions sin squared x and cosine squared x. Specifically, by rewriting cosine squared x in terms of the easily integrable function cosine 2x, we can thereby evaluate the cosine squared integral. And in similar fashion, by rewriting sin squared x in terms of cosine 2x, we can thereby evaluate the sine squared integral. Let's apply this to a definite integral. Consider the integral of cosine squared x from x equals 0 to x equals pi on 2, whose integrand can be written in terms of cosine 2x by the double angle identity. We can then evaluate the integral before substituting in our limits and simplifying our answer. Let's look at a more complicated example. The integral of the square root of 1 minus x squared from x equals 0 to x equals 1. Here, we shall use the method of substitution, where we set the substitution x to be sine theta, giving dx to be cosine theta, d theta. Please note that this substitution certainly wasn't obvious. We then change the limits. By evaluating the sine function at 0 and 1, we deduce that the new limits are 0 and pi on 2. Substituting everything in, our original integral in terms of x is transformed to the following integral in terms of theta. Which simplifies to the following, since 1 minus sine squared is equal to cosine squared. The integrand ultimately simplifies to just cosine squared theta. But note that this integral is exactly the same as the one from the previous example, which we evaluated to be pi on 4.